So I was talking about types of topology changes in STP. So as I discussed with all of you, first of all it was direct topology change. And third one was insignificance. So we are having these types of topology changes available in STP, and I said that in case of direct topology change, of course your convergence time will be
30 seconds.
And in case of indirect topology change, your
50
convergence
seconds.
time was around 50
50
seconds.
seconds.
And in case of insignificant, I think it was significant, right?
Yes.
Significant. Right? Insignificant topology change. So as I said that due to insignificant topology changes, your switches can generate TCN BPDUs, and also I said I told you that if any switch generates any TCN BPDU, or if any switch receives a TCN BPDU, then it will always set its MAC addressing time equal to 15 seconds, equal to forward delay timer, right? And by default your forward delay timer is configured as 15 seconds. That is why, and you must remember that default MAC address switching time is configured as 300 seconds on all Ethernet switches, right? But if there is any type of topology change, if there is any TCN, whether it is received from any other switch or it is generated by your switch, right, your switch will always set its MAC address switching time equal to forward delay timer, which is by default 15 seconds. And of course, due to this feature, there will be too much unknown unicast flooding in your network, right? So to prevent your network from unknown unicast flooding, what can we do? We can enable port far feature on all access ports, right? So very first thing that will happen in case of after enabling port far feature, that now if your access port comes up or goes down, your switch will not generate any TCN BPDU, right? And if your switch do not generate any TCN BPDU, then of course you know very well, you understand very well that your switches will not set their MAC address switching time equal to forward delay timer. So is there any problem now?
No.
All right. And then after enabling port fast feature on your access port, another advantage of port fast feature was like your switch port was directly moving into forwarding state without going through listening and learning state, because unnecessarily it was taking like 30 seconds to move into forwarding state. However, there cannot be any bridging loop in between and system and user, your computer and your switch, right? Have you got it? So I think all these things we already discussed in previous class, and today let's implement all these things, right? So first of all, we are going to implement all those things which we learned in previous class in STP, right? And then after I will go for STP protection and all, right? Because after it we are having another topic of STP, which is STP protection, and then after STP protection I'll go for RSTP, and then finally I'll go for MSTP. So all these topics we have to cover in STP, right? All these topics are still left. All right, so let's start this STP now. So let me do one thing. Its IP address is 155, right? So let me access all switches first of all. All right, so switch 1, 2, 3, 4. All right, first of all, let me copy their MAC addresses, right? So that we can see that which switch is gonna to be root bridge here in this diagram, right? So show version. Even you can also write these MAC addresses. See, this is the MAC address of switch 1. And this is the MAC address of switch 2. This MAC address is on switch 3. Is it visible? Jewel, is this notepad visible from you? All right, so here we are having these 4 switches available in this topology, and you know very well that how are they, how all switches are interconnected with each other. Like here we are using 21, 22, 23, 24, 19, 20, right? So you know very well, you betterly understand that what is the physical topology of all these switches. And now you know very well that which switch is going to be root bridge here in this diagram, because you can compare their MAC addresses, because by default their bridge priority is common on all switches, right? Because on all switches by default their priority is going to be 32768, right? And this time which switch is gonna to be root bridge?
Switch 1.
Switch 1. Okay. Yeah, switch 1, right? So switch 1 is gonna to be root bridge here. So let's check it out. Show spanning tree, right? So switch 1 has been elected as a root bridge here, as you can see, right? And let me show you that trunking must be there actually. Show interface is trunk. Yeah, trunking is there in between switch 1 and switch 3, and also in between switch 1 and switch 4, right? But there is no trunking in between switch 1 and switch 2. And you know very well that why trunking has not formed in between switch 1 and switch 2. So interface range fast Ethernet 1 by 0 by 21 to 22. Then you can say switch port more dynamic desirable. And now you will come to know, you will see that trunking will come up in between 2 switches automatically. Show interface is trunk, right? So in between switch 1, switch 2, switch 1, switch 3, switch 1, switch 4, trunking have came up, right? And as I said that switch 1 must be elected as a root bridge, and now you can see here that switch 1 have been elected as a root bridge. See, this switch is working as a root bridge, and as I said in previous class that all interfaces of root bridge will always be DP, and you can see here that all of them are working as a DP, designated port, right? And this time MAC address switching time is what? 15 seconds, and you must be I mean, you must be knowing that why have they configured their MAC address switching time equal to 15 seconds, because recently its trunk port came up, right? I mean, it went down and again came up, and as I said, that whenever any interface, whether it is access port or trunk port in STP by default, right? So it will generate TCN, and whenever a switch will generate TCN or receives TCN BPD, it will always set its MAC address switching time equal to forward delay timer, and by default forward delay timer is what? 15 seconds. So by default switches are gonna to configure their MAC address switching time equal to 15 seconds. That's why here you can see that their MAC address switching time is configured as 15 seconds, right? So of course it's all interfaces. Like here, first of all, let's check that how many VLANs are existing on this switch. 10 VLANs are there. Let me remove all VLANs from its database. Show VLAN brief. Now you can see that only VLAN 1 is there, and of course switch 1 must be root bridge for this VLAN 1, right? So you can see that this switch is working as a root bridge, right? Even it is showing you here that this bridge is the root bridge. And remember that if your switch is working as a root bridge, then its root ID and bridge ID must be same. So this time you can see that root ID and this bridge ID is same. Then you can move on switch 2, switch spanning tree. Of course it have accepted switch 1 as a root bridge. Now let me show you that what is your connectivity here between switches. So of course it is like switch 1, and then you are also having switch 2. I hope that all of you remember this connectivity, right? Because you have already done it. I mean, you have already done work on this topology during CCNP as well. So this time this is gonna to be your physical topology among all switches. So 19, sorry, this is 21, 22, 21, 22. It's going to be 19, 20, and here again 19, and this is going to be 20. And here in between switch 1 and switch 4 it's again going to be 23, 24. Then here again it is going to be 23 and 24. Between switch 2 and switch 4 it will be using 19, 20. Here at the end of switch 4 also it will be using 19, 20. In between switch 3 and switch 4 it will be using 21, 22, 21 and 22. Fine. So of course, as you know that switch 1 has been elected as a root bridge. So of course all interfaces of switch 1 must be configured as DP. So as you have already seen that all interfaces of switch 1 have been elected as a DP. So now on switch 2, first of all it will elect its RP. So which port is going to be its RP here? So of course 21 is going to be RP, and because this 22 at the end of switch 1 is already configured as DP, so at the end of switch 2 it must be in blocking state, because under non-DP you have only two things, either blocking or RP. I mean either blocking port or root port. So RP was already existing on this switch 2, so there was only one possibility, and that was blocking port, right? So that is why in this segment here at the end of switch 2 it have become blocking port, right? In same manner switch 3 will also elect its own RP. So 19 is gonna to be RP and 20 will be in blocking state. In between switch 1 and switch 4 again 23 is gonna to be RP and 24 will be in blocking state. Now you have to perform election in between switch 2 and switch 3, right? Switch 2 and switch 3, as you know that for DP election cost will be same here, right? Because it's going to be 23 here, and this is 24, this is 23, and this is 24. So here for the election of DP in between switch 2 and switch 3, you betterly understand that if you are going to elect DP in between two non-root bridges, right? If you are going to elect DP in between two non-root bridges, in that case for DP election, first of all it will start it from lowest cost to reach root bridge, right? So as I discussed in previous class, you must remember that here cost is going to be same from both ends, right? So next tiebreaker will be designated bridge ID, right? So now either switch 2 or switch 3, which switch is having best bridge ID? So I think so switch 2 is having best bridge ID, because you can compare their MAC addresses, because they are having by default priority, right? And by default their priority is 32768. It means by default bridge priority is common on switch 3 on switch 2 as well as switch 3. So finally they will be electing their DP based on MAC address, right? So either here you can compare their MAC addresses in between switch 2 switch 3. So which switch is having best MAC address among switch 3 and switch 4? So you can compare their MAC addresses here. I mean in between switch 2 and switch 3, and you can see that switch 2 is having lower MAC address. So finally this switch 2, I mean the end of this switch 2 must be configured as a DP, and here because it's not a DP, it will become non-DP, and under non-DP you can have either RP or blocking port. RP is already there, so of course both of them are going I mean both of them must move into blocking state, right? So that's why these two interfaces will become as a alternate port here for switch 3, right? And in same manner you are going to elect this DP election in between switch 2 and switch 4 as well, and here for DP election again it will be comparing their cost, right? So if BPD is coming from the direction of switch 1 to switch 2 and then towards switch 4, so whenever switch 4 will receive here BPDU, its total cost is going to be 38. And if BPDU is transmitted by switch 1 to switch 4 and then switch 4 will send that BPDU in the direction of switch 2, so the total cost to reach root bridge from switch 2 is again going to be 38. So from both ends the total cost to reach root bridge is going to be same, right? I mean is same. So if total cost to reach root bridge is same, the next tiebreaker is what? Designated bridge ID. So switch 2 or switch 4 is having best bridge ID? Of course switch 2. So the end of switch 2 is going to be again DP, and of course here because RP is already elected, so both of them will move into blocking state. In same manner election will be done in between switch 3 and switch 4. So now you can compare MAC addresses in between switch 3 and switch 4. So I think so that switch 4 is having best MAC address, right? So of course here it must be DP, here it must be DP, here on switch 3 must be in blocking state. So now I'm gonna to see output of switch 3 except 19, all others must be in blocking state. So let me show you now. On switch 4, 23 must be RP, 24 must be in blocking state, 21 and 22 must be configured as DP, whereas 19 and 20 must be in blocking state. So let's move on switch 4 now and configure this command switch spanning tree. See 19, 20 alternate ports, 21, 22 DP, 23 is working as RP, and 24 is again in blocking state. So as we elected, right? So now we can move on switch 2. 21 must be RP, 22 must be in blocking state, and apart from 21 and 22 all must be DP. So let's move on switch 2 now. So spanning tree. You can see 21 is RP, 22 is in blocking state, and except 21 and 22 all others are DP, designated port. So is there any problem now in the election of RP, DP, DP and non-DP and the root bridge election? So of course like it is same as like we discussed in previous class, right? So we have already discussed all these things in previous class as well. So today first of all I will show you that what is the impact of insignificant topology changes on your network, right? So as I said earlier on that whenever any access port will come up or will go down, right? Not only access port, if any switch port in your switched environment comes up or goes down, your switch will be responsible to generate TC and BPDU, right? And it will transmit, your switch will transmit the TC and BPDU in the direction of root bridge, and then further root bridge will be responsible to propagate the TCN information throughout the switched network. Is there any problem? As I said earlier on, right? Like if TCN has been generated by non-root bridge, then non-root bridge will be responsible to transmit the TCN BPDU in the direction of root bridge. And then finally whenever root bridge will generate any configuration BPDU, inside configuration BPDU it is already having a flag of TCN. So with the help of the TCN flag it will propagate the TCN information throughout the switch network, so that all switches will configure their MAC address aging time equal to 15 seconds. And due to this problem, yeah, of course it is necessary to generate TCN BPDU in case if your trunk port comes up or goes down, right? But of course it is not necessary to generate this TCN BPDU whenever your access port comes up or goes down, right? So because if any access port comes up or goes down, and you know very well that in a live network, in a production network, access ports will come up and also will go down frequently, right? Because some of the users will shut down their machines, some of the users will turn on their machines, so every time your access port will come up and also will go down, right? So switches will always set their MAC address aging time equal to 15 seconds, right? And if all switches set their MAC address aging time equal to 15 seconds, it means there will be too much unknown unicast flooding in your network. So to prevent your switched network from too much unknown unicast flooding, what can we do? We can enable port fast feature on all access ports, right? Because by default your access port takes 30 seconds to move into forwarding state. However, there is no possibility to form a bridging loop. I mean, of course bridging loop cannot form in between end user and station and your switch. So unnecessarily it was taking like 30 seconds, right? So let's prove it now. So we are on switch 1 now, and port fast feature is by default disabled, right? So there is no port fast feature enabled on this switch, and now I'm gonna to show you that if any access port comes up or goes down, this switch is gonna to generate TCN BPDU, right? So however, this switch is already working as a root bridge, right? So it will not generate this TCN separately because it is responsible to generate configuration BPDUs. So it will add the flag of TCN BPDU inside configuration BPDU itself, right? So you know very well that all other switches will also set their MAC address aging time equal to forward delay timer, means that 15 seconds. So right now its MAC address aging time is what? 300 seconds. Even you can also check it on other switches as well. Like on switch 2 also it is by default now 300 seconds. On switch 3 also it will be by default 300 seconds, and on switch 4 also it will be by default 300 seconds. Any problem? Okay, so let's do one thing now. Let's move on switch 1 and say debug spanning tree events, and now I'm gonna to move on R1, and on R1 what will I do? I will say on FA 0 by 0 and no shutdown, right? So now you know very well R1's 0 by 0 is connected with switch 1 0 by 1, and you will see that now your switch will put this interface into listening state, and again it will remain there for 15 seconds, and then after 15 seconds it will move into learning state, and again it will remain there for 15 seconds, and finally it will move into the forwarding state. Now you can see over there, and once your switch will put this interface into forwarding state, it will be responsible to generate TCN BPDU, right? And if the switch generates TCN BPDU, then also it will set its MAC address aging time equal to, you see it have generated TCN, right? This is TCN BPDU actually, right? So now you can see show spanning tree. Now its MAC address aging time must be configured as 15 seconds on other switches as well. On switch 2 MAC address aging time must be configured as 15 seconds. On switch 3 also MAC address aging time must be configured as 15 seconds. On switch 4 also MAC address aging time must be configured as 15 seconds. Fine. So unnecessarily all switches have configured their MAC address aging time equal to 15 seconds. So now to prevent your switch network from such kind of things, we can enable port fast feature, right? So this time I'm gonna to enable port fast feature here on switch 1, and then after enabling port fast feature on all access ports, you will see that now if your access port comes up, then it will directly move into forwarding state without going through listening and learning. I mean it will simply skip listening state as well as learning state, and it will directly jump from blocking into forwarding state. And also your switches will not generate any TCN BPDU if your access port comes up or goes down. So let me do one thing now. Interface fast Ethernet. Even if you shut down this access port, then also it will generate TCN BPDU, right? Let me show you. So spanning tree. See, again its MAC address aging time has been configured as 300 seconds, and let me show you debug spanning tree events, and on R1 let me shut down this interface. So if you shut down your interface, then also your switch will be responsible to generate TCN BPDU, as you can see here, right? And once again they will set their MAC address aging time equal to 15 seconds. Any problem now? So whether access port comes up or goes down, in both cases your switch will generate TCN BPDU. However, it is not required for a switch to generate TCN BPDU if any access port comes up or goes down. Yeah, it will always be mandatory for a switch to generate TCN BPDU if any trunk port comes up or goes down. So this time on switch 2, what I'm gonna to perform here on FA 0 by 1, I'm gonna to enable port fast feature. So now you can see show spanning tree, port fast. That's it. In this way you can enable this port fast feature for a specific interface, right? And also you are having another command by which also you can enable your port fast feature on a switch, and it will be global command actually, and the command will be spanning tree port fast default. So if you configure this command, means that now port fast feature will automatically enable on all access ports, not on trunk ports, right? If this command doesn't mean that port fast feature will also get enabled on trunk port. Don't think like that. Port fast feature, I mean if you enable this port fast feature globally, doesn't mean that it will also get enabled on trunk ports, right? Still it will get enabled only on access ports. So this time after enabling this port fast feature, and one more thing, that if you want to see that whether port fast, I mean global port fast feature is enabled in STP or not. So for that the command is going to be show spanning tree summary. By running this command you can confirm whether port fast default feature is enabled or disabled, right? So by default it is disabled, but you can enable it by using command spanning tree port fast default, right? So in this way you can enable it. So is there any problem? And now I will show you that what will be an impact of enabling. Okay, so after enabling this port fast feature on this switch, let me show you that how is it gonna to do work. See, I shut down. Let me do one thing, show spanning tree. Now by default all switches have configured their MAC address using time equal to 300 seconds. Debug spanning tree events, and let's move back on R1 and let's say no, shut down. This time you will see that switch port on switch 1 will directly jump from blocking into forwarding state, and also will not generate any TCN BPD. Have it generated any TCN?
No.
Have it given you any log message that it generated any TCN BPDU? And because of it have not generated any TCN BPDU, so that all switches will remain there. I mean will keep their raging time equal to 300 seconds. So you can also move on switch 2. You will also find that on switch 2 also MAC address raging time is by default 300 seconds. So this time switch 1 have not generated any TCN BPDU, right? So that all other switches are also having their default MAC address aging time, because this time when access port came up, at that moment switch 1 didn't generated any TCN BPD, right? Okay, and also you can see that port directly jumped from blocking into forwarding state. And in case if this switch port goes down once again, let's say you have shut down this interface now once again, so you will see that this interface will go down on switch 1, but it is not going to generate any TCN BPDU. So after enabling port fast feature, you can see now that switches are not generating any TCN BPDU if any access port comes up or goes down, right? And of course after enabling port fast feature, you can also see that if any access port comes up, then it is directly jumping from blocking state into forwarding state. So this is the advantage of enabling port fast feature on your switches, and this is really mandatory for you guys, right, to enable port fast feature globally on all switches. You know why? Because unnecessarily your access ports will take at least 30 seconds to move into forwarding state. And also if you do not enable port fast feature, default port fast feature in your on all switches in your switch network, then of course there will be too much unknown unicast flooding. So to prevent your network from such kind of problems, you can enable this port fast feature in your network. Now next thing is direct topology change. So this time I'm going to show you that what is an impact of direct topology change and what will be convergence time in case of direct topology change. As I have already discussed it with you that default convergence time of direct topology change is 30 seconds, right? So this time we are going to prove all those things. So this time what will I do? I will draw this diagram. Actually I will be having only two switches. One is switch 1 and another one is what? Switch 2. So I will interconnect only switch 1 and switch 2 together, right? And they are interconnected with using 21, 22, 21 and 22. And this time what will I do? I will connect this R1 to switch 1, and you know very well R1 0 by 0 is connected with switch 1 0 by 1, right? And I will connect this R2 with switch 2, and you know very well R2 0 by 1 is connected with switch 2 0 by 2, is not it? and I'll be using these routers as an end host. And this time, because switch 1 is configured as a root bridge, so because switch 1 is configured as a root bridge, then 21 is gonna to be DP, 22 will also be DP, and 21 will become RP, and 22 will remain in blocking state. Then I'll show you that because this switch 2 is having alternate port, right? So direct topology change can occur only on that switch which is having at least one alternate port. So this time switch 2 is having this alternate port. So if this RP goes down on switch 2, then you will see that immediately it will put this alternate port into listening state, and it will take at least 30 seconds to put this alternate port into forwarding state as RP. You understand? So now we are going to prove all these things, and during those 30 seconds there will not be any communication between these two lane users, between these two hosts, right? So let me do one thing. First of all, I will move on R1. Let me allocate an IP address to its FA0 by 0. Let's say it is 12.1.1, and then let's move on R4, because here there is no R2, so let's use R4, and you know R4 0 by 1 will be connected to 0 by 4 of switch 2. So let's move on R4 now, and on R4 I will allocate its IP address 12.1.1.2. On R1 I allocated 12.1.1. So let's move on R4 now. On its FA0 by 1, IP address is going to be 12.1.2. And let me do one more thing. Let me shut down all other interfaces available on switch 1 as well as switch 2. Interface range fastest net 1 by 0 by 19 to 20, and then 23 to 24. Now switch 2 will be connected with switch 1 only. So spanning tree, you must understand that 21 will be elected as RP and 22 block, and on switch 1 both of them will be DP. So there is no problem because DP is already in forwarding state. So it will not take it will not go through listening, learning and all states, right? Because it is already in forwarding state. So let's move on switch 2 now. So now if you try to communicate from R4 with R1, you must be able to communicate with R1. It's not it. When you can repeat. So there must not be any problem in communication between these two lane users. Is there any problem now? Alright, so let's do one thing. Let's move on switch 2 and say debug spanning tree events, and let's shut down this 21. So you will see that immediately this switch 2 will put this alternate port into listening state. You see, and there will not be any communication now. See, data is getting dropped now, and it will be getting dropped for 30 seconds because it have moved now into the learning state. So after 15 seconds it will move into forwarding state. And once it will move into forwarding state, you see again traffic have started to exchange in between these two hosts, right? So how many packets were dropped? You can count them. 16. But in some cases you will also see that only 15 packets will get dropped, right? I mean 15 or 16 maximum, because your the convergence time, not aging time actually, your convergence time is what? 30 seconds in case of direct topology change, right? So for 30 seconds there will not be any communication between the lane users behind both switches, right? So now you can also see here on switch 2 that at sharp 4753 it moved into listening state. Then at sharp 4823, which will come after 30 seconds, It's not it have moved into forwarding state. So in case of direct topology change, their convergence time will be 30 seconds. To prevent or to reduce this time, we can use here uplink fast. So this time I'm going to implement this uplink fast feature over here, right, to prevent our network from this kind of problem, because 30 seconds is too much, right? It's too much. So let's do one thing, unall, and one more thing. The another problem is like debug spanning tree events. Let's again move back on R4 and let's start to communicate with R1. Of course it is communicating, right? But in case if your primary root port comes back up on switch 2, and again you will see that it will take 30 seconds, another 30 seconds. See, again for another 30 seconds there will not be any communication between their lane users. You see, traffic have started to getting dropped. So is there any problem now? Have you understood it now? So this is the problem in case of normal STP, that whenever primary RP will go down, alternate port will again take at least 30 seconds to move into forwarding state. And in case again if your primary root port comes back up, then again there will be convergence time of 30 seconds. That is the big problem here in STP. As you can see, again you can move back on switch 2. You see that when we said no shutdown, 21 moved into listening state and 22 moved back into blocking state. Fine. So this is the problem in STP in case of direct topology change. Now after it, let's enable uplink fast. So where will you enable uplink fast feature on your switch?
Access ports.
I mean, where can you enable this uplink fast feature? Where? You can enable uplink fast feature only on that switch which is having at least one alternate port along with RP. If your switch do not have any alternate port along with RP root port, there will not be any advantage of enabling uplink fast feature. You know why? Because if you are having root port and along with root port you are also having alternate port, blocking port, right? After enabling uplink fast feature, if your primary RP goes down, then it will directly, your alternate port will immediately move into forwarding state. So you will not require to do wait for 30 seconds. Have you got it now? Alright. And in case if your primary, let's say that after some time if your primary root port comes back up, previously as you have seen that again it was taking 30 seconds, right? The convergence time was 30 seconds, but after enabling uplink fast feature, if your primary root port comes back up, in that case it will not take 30 seconds. There will not be any outage in your switched network, right? Due to uplink fast only. However, it doesn't mean that whenever your primary RP will come up, it will directly move into forwarding state. No, it will not directly move into forwarding state. It has to do wait for some time interval. But during that time interval, there will not be any outage in your switched network. So I'm gonna to prove all those things now, right? So this time you can see that on switch 2, you are having one RP, and along with RP root port, you are also having this alternate port. So this switch is suitable to enable uplink fast feature. Once you will enable this uplink fast feature on this switch 2, you will see that if your RP goes down, if your 21 goes down, then 22 will directly move into forwarding state immediately. Fine. So let's prove all these things. One more thing I would like to tell you, that if you are planning to enable uplink fast feature on your switch, make sure that your switch must be having default bridge priority. If your switch is not having default bridge priority, and then after if you enable uplink fast feature on your switch, then uplink fast feature will not take place. Let me show you. For an example, let's say that switch 1 is having its priority as 0, spanning tree VLAN 124094. Priority is what? 0. So this time I have enabled, I have configured its priority as 0, right? So now you can see show spanning tree. This switch 1 will become, of course it will remain as root bridge. Previously also it was root bridge, but this time it is having its bridge priority as 0. Now let's move on switch 2 now. Let's configure its bridge priority as spanning tree VLAN 1 priority as 4096, and you must remember that you can allocate priority in the increment of 4096 only. So on switch 1 I configured 0, so that switch 1 will will remain as root bridge, and now I configured 4096 on switch 2. So I configured this value here on switch 2 because I wanted to show you that if you do not have default bridge priority on your switch, then uplink fast feature will never take place, will never work, right? So this time this switch is not having default bridge priority, as you can see here. Show spanning tree. So this switch is having its bridge priority now as 4096. And now if you try to enable uplink fast feature here on this switch spanning tree uplink fast, it will show you that uplink fast has been enabled here. Show spanning tree uplink fast. You will see that uplink fast feature is enabled, but there will not be any advantage of enabling this uplink fast feature on this switch this time. Show spanning tree, as you can see here that 21 is configured as RP and 22 is in blocking state, working as alternate port, right? So in case if you 21 interface FA0 by 21 goes down, right? If this 21 goes down, then you will see that 22 will not directly move into forwarding state. Let me show you. So listening, it is still in listening state, right? And it will take like 30 seconds to move into forwarding state even after enabling uplink fast feature. So even on your switch you can enable uplink fast feature, but it will never take place if your bridge priority is not configured as a default bridge priority. So you must remember all these things before going to enable uplink fast feature on your switch, right? So this time what will I do? I'm going to configure, I'm going to remove that command by which I configured its priority as 4096. So let me remove that command first of all. Once I will enable this uplink fast, once I will disable this priority, I will remove this priority, manually configured priority from this switch. You will see that previously when I said show spanning tree, did it show us that uplink fast is enabled here? No, but this time after removing this command spanning tree VLAN 1 priority 4096, now you will come to, now you will see that its priority will be configured as its default priority, which is by default 32768. So this time you will see that by default its priority will be 32768, but along with that you will also come to know that uplink fast is now enabled. So remember that if you are going to enable uplink fast feature on any switch, then its priority must be configured as default priority, right? So after enabling this uplink fast feature, now let me show you one faster than a 1 by 0 by 21. Let me say no shutdown. You will see that 21 will become RP, new RP once again, because 21 is having best credentials as compared to 22. That is why 21 will be elected as a RP. So let this 21 came up as root port, and then after again I will shut down this 21 and I will show you that this time immediately this switch 2 will put this 22 into forwarding state. Let me show you that. Of course, I'll tell you changes after enabling a break fast feature on your switch. Don't worry about that. I'll discuss all those changes which will be applied on your switch after enabling uplink fast feature, right? Today I think these ACs are not working at all.
Priority will be same on all switches
What?
or only particular switch?
Let me show you. What? Uplink fast. Uplink fast will always get enabled globally. You cannot enable this feature per interface. See, 21 has been configured once again as RP, right? Then after, let's say that okay, this 21 is RP now and 22 is alternate port, and uplink fast is enabled on this switch now, right? So let me do one thing now. Once again, and one more thing, I'm gonna to ping from R4 to R1. You see that it is pinging R1 successfully without any problem, right? And once again I will move on switch 2. Let me show you debug spanning tree events, and again I will say 21 is what? Shut down. So this time you will see that 22 will directly move into forwarding state, and it have moved actually. You see 22 has moved already into forwarding state, and you see that communication is there without any problem, right? So this time your convergence time is like less than 2 seconds. However, at least one packet will get dropped, but end users will not experience this outage, this type of outage, and users will never be able to experience it unless you are not doing any voice call. Because if you are doing any voice call and if any single packet gets dropped, it means there will be some problems in your voice. So I hope that you have understood the uses of uplink fast feature. And one more thing I would like to show you here. Let's again ping to R1. It will keep on to ping R1, right? And once again, let's say this 21 have came up. Previously, without enabling uplink fast feature, we saw that it was again taking at least 30 seconds, but this time you will see that there is no problem actually. See, still your R4 is communicating with R1, is not it? However, it doesn't mean that your 21 will directly come up and will move into forwarding state as RP. No, because there is a timer which is known as root port delay timer, and which is by default 35 seconds. So once your primary root port will come up, then it will activate your root port delay timer, which is by default 35 seconds, right? So it will wait for next 35 seconds. If there is no problem for next 35 seconds with primary root port, then it will directly put that primary root port into forwarding state and will directly put that 22 into blocking state. Wait, I'm coming there. You see, there is no problem at all in between communication between the lane users, right? There is no problem. However, again it will drop at least one packet. Let me show you. Oh my god. I can't search that, but of course it must drop at least one packet. But you can see here that when we say no shutdown, when we configure this command under 21, it came up, right? It came up immediately, and you see that it moved into listening state, right? And when it moved into listening state, it started its root port delay timer, which is by default 35 seconds, right? So 21 waited for 35 seconds, and then after 21 directly moved into forwarding state, you see, and at same time 22 moved back into blocking state. So there was no outage in your switched network when your primary root port came back up. Any problem? Now you could ask me that why is it taking these 35 seconds? What is the uses of this? See, you understand that 30 seconds will be for listening and learning state, right? And 5 seconds for PHEP negotiation or LACP negotiation if you have configured Ether channel. Might be that you have configured Ether channel, and after enabling it, after configuring Ether channel in between two switches, you know very well that the port channel would be there, right? Port channel would be there. So if any member port of a port channel comes up or goes down, let's say it have came up, right? So of course PHEP will require at least 5 seconds to perform negotiation, right? So 5 seconds for PHEP or LACP and 30 seconds are for listening and learning state once again. However, it will not show you that now your switch port is going through listening and learning state. But Due to listening and learning state, it will take 30 seconds, and due to PAGP, I mean due to ether channel negotiation, it will take 5 seconds. That is why total time will be 35 seconds, and this is known as root port delay timer.
Now, in case of media channels, when an media channel is configured, STP is running. So STP will consider a port channel as a single port. Right?
Exactly.
So if an individual port goes down and comes back up, will it still transition to these states? Like listening, learning, forwarding, or it will directly go from
STP does not understand your physical port. That is why I said that PAGP will take at least 5 seconds to perform negotiation, right? So PAGP will make that interface member of your port channel, right? Is not it? And again, port channel, because port channel was working as RP, just try to understand it in this manner. For an example, you are having 2 port channels available in between 2 switches, right? Here one port channel is configured here with using 2122. Let's say switch 1 and switch 2 are also interconnected with using some other interfaces as well, right? So another port channel will be there, right? So if any, of course this time any one of the port channel will be RP. So let's say that this is, have you understood it now? This is RP and it was in blocking state. Now of course you would always like to enable uplink fast feature on this switch, right? So after enabling uplink fast feature, if this RP goes down, it means that if this port channel goes down, then it will directly put this port channel into forwarding state. Now let's say that again these interfaces have came up, right? So 5 seconds will be taken by PAGP to negotiate this ether channel, is not it? And then again, because this port channel will take 30 seconds to move into forwarding state, listening and learning state, right? That is why now you can see that at least 35 seconds will require. That's called actually root port delay timer. Root port delay timer, which is by default 35 seconds. You see, it started at sharp 32. After adding 35 seconds, see, 107, is not it? 21 have moved into forwarding state. Ask me. Yeah, there is no outage because 22 for that timer, during that timer your alternate, I mean 22 will remain in forwarding state.
If alternating or come down,
Then of course then you can't do anything. Then again there will be outage. Now you are saying that your primary RP went down and now secondary have also gone down, then you can't do anything. Is not it? So I hope that now you have understood the concept of this uplink fast. One more thing, after enabling uplink fast on a switch, there will be some changes in your switched network. Like on that switch where you enables uplink fast feature, it will configure its bridge priority. Let me show you. It will configure its bridge priority as 49152. It will change its bridge priority from 32768 to 49152, and also it will add cost by 3000 on each interface. Like by default its cost was 19, but this time you can see that its cost have become 3019. So you must be you must have this information, or you must have this knowledge that why is it necessary to configure its bridge priority from 32768 to 49152, and also its cost by from 19 to 3019 after enabling uplink fast feature. So what's the requirement of it?
so that it never becomes root.
See, it will change its bridge priority from 32768 to 49152, so that it will never become root bridge. So that it will never become root bridge, and it will always keep at least one alternate port. Because if this switch do not have any alternate port, then there will not be any advantage of enabling uplink fast feature. Just like for an example, if you move on switch 1, of course there is no RP and alternate port available on this switch 1, and if you enable this uplink fast feature on this switch 1, it's not gonna to have any impact on this switch. So this uplink fast feature can have impact only on that switch which is having at least one root port, and also along with root port it must have at least one alternate port. If you do not have any alternate port available on your switch, in that case uplink fast will never have any impact on your switched network. So it is really mandatory that your switch must be having at least one alternate port along with root port. So because we said that okay, switch 2 was having root port, and along with root port it was also having one alternate port, right? So once I enabled here this actually I enabled here uplink fast feature, and then after enabling uplink fast feature it configured its bridge priority from 32768 to 49152 just to ensure so that it will always keep that alternate port, because in case if there is any topology change in your network, might be your switch will not have this alternate port. Let me show you how can it be possible. For an example, let's say that you are having this type of diagram, switch 1 and this is switch 2, and let's say this is switch 3. Let's say this is 0 by 1, this is 0 by 2, this is again 0 by 1, 0 by 2, 0 by 1, and this is let's say 0 by 2. Okay, let's say its MAC address is A, this is B, and this is C. So it's gonna to be DP now, it's gonna to be RP, and it will be RP here, and here it is going to be DP, and it was, let's say it will be in blocking state. Fine. Now you came to know that okay, switch 3 is having one alternate port. So of course in this diagram you can enable this uplink fast feature only on switch 3. You cannot enable this this feature either on switch 1 or switch 2, right? Because they do not have any alternate port available, right? So this time only switch 3 is having one alternate port available in its like in STP, so that you can enable this uplink fast feature only on switch 3. Now let's say you have enabled here uplink fast feature, then after what you made some changes here. Let's say you configured here its cost as 10, you changed its cost from 19 to 10, and now you know very well after changing its cost it will become DP and it will become. So will there be any impact? Will there be any effect of enabling uplink fast feature on this switch 3? Tell me. That is why it is really mandatory to change its cost as well as to change its bridge priority. Have you got it? Hello? Might be, and also it was also possible that let's say that you were also having some other switches behind switch 1, you are having another switch and it was configured as a root bridge, and all of them were having default bridge priority. So root bridge election was performed based on their MAC address. So this switch was having best MAC address, this switch 4, right? This is, let's say, switch 4. So this switch 4 was connected to switch 1, right? So switch 4 was elected as a root bridge. Now switch 4 has gone down, and among all these three switches, let's say switch 3 is having now best MAC address because all of them were having default bridge priority. So in this case switch 3 can also become root bridge, is not it? So again there will not be any impact of enabling uplink fast feature on this switch 3. That is why it is necessary to change cost of the interfaces, and also it is also necessary to change their bridge priority from 32768 to 49152. So I hope that now you have understood that what is the requirement of changing the cost of each interface and of course bridge priority. Have you understood it? So once it will change its bridge priority to 49168, and also its cost from 19 to 3019, then after you will see that it will always keep, in all conditions it will keep this alternate port actually. And then after, if it's this primary root port goes down, you will see that uplink fast will immediately put this alternate port into forwarding state. Fine? Didn't get it? See, my question was, that why switches have configured, I mean after enabling uplink fast feature, why switch configures its bridge priority as 49152, because by default it is 32768. So now this switch 3, after I just enable uplink fast feature, right? After enabling uplink fast feature, switch 3, I mean like here you can see on switch 2, if I disable, let's say no spanning tree uplink fast, do show spanning tree, again you will see that by default its bridge priority will be 32768, right? And now uplink fast is not enabled, right? Once you enable uplink fast, and default cost is what, 19. So if you say uplink fast, spanning tree uplink fast, after enabling this uplink fast feature, you will see that now its bridge priority will become 49152 and cost will become 3019. So I was just telling you that what is the requirement of configuring its bridge priority from 32768 to 49152, and also its cost from 19 to 3019. So first of all, let me discuss you that why is it necessary to configure its priority from 32768 to 49152. As I said that if you are having this type of diagram, like you here, you are also having one another switch 4. This is switch 4, and all switches, all these 4 switches were having default bridge priority which is 32768 based on MAC address, because let's assume that switch 4 was having best MAC address, right? So it become root bridge, and because switch 4 was working as a root bridge, so it was DP and it was RP, then these both interfaces became as DP, and here on switch 3 you were having this port as blocking port and it was RP, right? So everything was in this manner actually. Now accidentally this switch 4 has gone down now, so again there will be reconvergence of STP, is not it? Because your root bridge has gone down, so there will be reconvergence of STP, and now this time there will be new root bridge election among switch 1, switch 2 and switch 3, and this time let's assume that switch 3 was having best MAC address among all these 3 switches. So this time switch 3 will become root bridge. Will there be any advantage of enabling uplink fast then? So it is really necessary for that switch where you have enabled uplink fast to keep at least one alternate port. So how will it be possible for that switch where you have enabled uplink fast to keep at least one alternate port? To achieve that task, actually it have changed its bridge priority from 32768 to 49152, because now in case this switch 4 goes down, then there will be reconvergence of STP among these 3 switches, right? So of course there will be new root bridge election between these 3 switches. So because switch 3 is already having its higher bridge priority than switch 1 and switch 2, so of course switch 3 will never participate in root bridge election, because it already have its bridge priority higher than switch 1 and switch 2. Fine. So of course switch 3 will never become root bridge in case of any change in your STP topology. Is there any problem? Okay, now it also changed its cost from 19 to 3019. As I simply discussed with you, let's say it was RP, it was alternate port, right? So in case if someone changed its cost of 0/2 from 19 to 10 now, so it will again perform, again there will be reconvergence in STP, right? And this time you understand very well that it will become DP and it will become alternate port, is not it? So of course you will never like to have this type of topology now, because you have not enabled uplink fast feature on switch 2, you just enable uplink fast feature only on switch 3. So it is really mandatory for switch 3 to keep this alternate port to have an impact of this uplink fast feature, right? So how will it be possible? For that purpose, it will also add its cost per link by 3000. And also there is one another reason, so that there will be uses of this higher cost. I will let you know later on, right? I'm just going to discuss that situation with all of you. Just give me 1 minute or 2 minutes, right? So I hope that now you have understood that what is the reason behind these types of changes. One more thing. Now my question to all of you, for an example, this is switch 1, this is switch 2. Once again I will be having only 3 switches. This is switch 3. Its MAC address is A, its MAC address is B, and its MAC address is C. This is 0/1, this is 0/2, this is 0/1, and this is 0/2, this is 0/1, and let's say again this is 0/2, right? So it's gonna to dp, it's gonna to be dp, this is rp, this is again rp, this is gonna to be dp, and it will remain in blocking state. Right now you are having a user behind switch 2. Let's say its MAC address was D and it was connected via 0/3, and you are having one another user behind switch 3, and let's say that its MAC address is E and it is also connected with 0/3. Now what will be MAC address table of all switches? Let me populate it. On switch 3, on 0/2 it will learn D, on 0/3 it will learn E. According to switch 1, on 0/1 it will learn D, on 0/2 it will learn E. On switch 2, on 0/1 it will learn E, and on 0/3 it will learn D. This will be MAC table actually of all switches. Fine. Now let's assume that this interface has gone down. Fine. Good. You know very well it will become now new RP and will directly immediately will move into forwarding state. And because this link has gone down, this 0/2, so of course this switch 3 is gonna to remove this entry immediately from its MAC table. But is there any, is this 0/1 have gone down on switch 2? So of course this switch 2 will keep this entry on 0/1, is not it? That MAC address E is reachable via 0/1. However, changes have occurred on switch 1, interface has gone down, trunk port have gone down, so switch 1 will generate TC and BPDU, right? So that now switch 2 will configure its MAC address aging time equal to 15 seconds, is not it? It will configure its MAC address aging time after equal to 15 seconds, right? So it will remove this entry, this MAC address E from its MAC table after
15 seconds.
if it performs something like this. For next 15 seconds there must not be any communication in between these two end users. You know why? Because whenever this D will transmit any traffic towards E, this switch 2 will always transmit it out from 0/1. And will it be possible to reach that host out from this interface?
No.
So of course there must not be any communication between these two lane users for next 15 seconds. Was that happen? Was that, like as I configured this uplink fast feature in between these two switches, switch 1 and switch 2, and we have seen that if 21 was going down, then only one packet was getting dropped, not more than that. Was there any outage in your switch network for 15 seconds?
No.
So it means that switch updated its MAC table immediately. So what was the reason behind it? How was it possible for switches to populate, to update their MAC table immediately? Because if we are relying on TC and BPDU, then of course switch must take at least 15 seconds to update its MAC table, right? So what is the component, or due to what switches are updating their MAC address table immediately? Because this time they didn't wait for 15 seconds as we have seen it. See, for that purpose, after enabling uplink fast feature, you must remember it will always start to multicast dummy frames at a rate of 150 packet per second. Remember, after enabling uplink fast feature on a switch, it will also start to multicast dummy frames at rate of 150 packet per second. Let me show you that by default it is enabled, right? So because uplink fast, we enable uplink fast feature on switch 2. Let me show you, show spanning tree uplink fast. So you will also come to know that station update rate set to 150 packet per second. So remember that after enabling uplink fast feature, your switch will start to send multicast dummy frames at rate of 150 packet per second. Fine. Now let's say you have enabled uplink fast feature on switch 3, right? Fine. You know very well that if this RP, primary RP, goes down, it will immediately put this interface into forwarding state. Is not it? And it will become new RP. Fine. At same time, switch 1 will generate TCN BPDU. So it means switch 2 will configure its MAC address switching time equal to 15 seconds. Is not it? Fine. At same time, switch 3 will also transmit dummy frames. Switch 3 will multicast dummy frames at rate of 150 packet per second. What does it mean? What's the meaning by dummy frame? See, after enabling uplink fast feature on this switch 3, you know, if this RP, primary RP goes down, then this alternate will immediately move into forwarding state. Then after it, I mean, once this switch 3 will put this alternate port into forwarding state, at same time it will start to transmit dummy frames at rate of 150 packet per second, and in those dummy frames, source MAC address and destination MAC address must be specified. Is not it? Because frame cannot be formed without having source MAC address and destination MAC address. Because as I said, that switch 3 will be responsible to transmit multicast frames. So destination MAC address will be a multicast MAC address. Fine. And source MAC address is in those dummy frames will be those MAC addresses which are available in the MAC table of switch 3. So you know very well that switch 3 was already having this MAC address E inside its own MAC table. Is not it? Might be it will also be having some other MAC addresses too in its MAC table. So in that case, whenever it will transmit those dummy frames out from this interface, in those dummy frames, source MAC address will be those MAC addresses which are available inside the MAC table of switch 3. So this time it is having only this MAC address E available inside its own MAC table. Fine. So whenever it will transmit that dummy frame out from this interface, out from this new RP, then in the source of that dummy frame will be E and destination will be multicast MAC address. So this time whenever switch 2 will receive this dummy frame here 0 by 2, because MAC address is in time have been configured as 15 seconds now. Is not it? So it will, whenever it will receive this frame here on its 0 by 2, source MAC address will be E. So it will learn, or it will come to know that now device which is having MAC address E is connected via this interface. So it will immediately update this entry that it is not 0 by 1, it is 0 by 2. That is why there will not be any outage in your network due to any change in your topology. Have you understood it now? That how switches will update their MAC table after enabling uplink fast feature? Tell me. So might be that switch 3 will be having like 100 of MAC addresses or 1000 of MAC addresses available in its MAC table, right? So to update the MAC table of switch 2 immediately and also MAC table of switch 1 immediately, because it is multicasting those frames, right? So once switch 2 will receive that multicast frame coming from switch 3 on its 0 by 2, it will also send one copy of that multicast frame towards switch 1. So switch 1 will also update its MAC table accordingly immediately. It means all switches in your switched environment will update their MAC table immediately. Is not it? So this is that how your uplink fast works. Now we do not have anything left in uplink fast. If you are having any confusion related to uplink fast, please do let me know.
And for how long does the switch 3 send your
Dummy frames, right?
For how long?
It will always keep on to generate these dummy frames after enabling uplink fast. That is why after enabling uplink fast there would be some overhead on your network, extra overhead.
CPU.
And in case if primary RP comes up again, then it will also start to generate dummy frames out from that interface. It will always keep on. That is why there will be some extra overhead on your network after enabling uplink fast feature. And let me tell you one more thing now. There are some disadvantages as well after enabling uplink fast feature. In live networks, in production networks, your network design will be something like this: core layer, distribution layer, and finally access layer. Fine. Let's say this is switch 1, this is switch 2, switch 3, switch 4. This is core layer, this is distribution, and then after you are having access layer switches. Switch, 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 switch. Because this time distribution layer switches will also be having alternate port, is not it? If you enable, let's say that you have enabled uplink fast feature on switch 4. If you have enabled uplink fast feature on switch 4, then definitely it will increase its bridge priority and also its cost. Will it be responsible for access layer switches to transmit data in the direction of switch 4? In the presence of switch 3. If switch 3 is present in your network, then will it be possible for any single access layer switch to transmit data in the direction of switch 4 towards core?
No.
Of course no. It will never become the best path. It will never become the best path for access layer switches. That is why you cannot enable uplink fast feature in this type of network, in this type of diagram. So you cannot get load balancing, is not it? So it is always desirable, or it is always recommended to enable uplink fast feature only on access layer switches. Have you understood it now? You cannot enable this uplink fast feature either on core layer switch or on distribution layer switch due to load balancing only. Any problem now? Sure. I have also shown you, we have seen that how uplink fast works actually, right? I have also taught you that what are the advantages of enabling uplink fast feature and what are the disadvantages of enabling uplink fast feature in your production network. Fine. That's all about the uplink fast feature. Now let's talk about backbone fast. Because in previous class I also discussed about indirect topology change. So if you talk about the indirect topology change, even we can also prove it. Like for an example, if you are having this type of diagram, let's say this is switch 1, this is switch 2, and this is switch 3. Its MAC address is A, B, C. 0 by 1, 0 by 2, 0 by 1, 0 by 2, and this is, let's say, 0 by 2, 0 by 1. Any problem? So it's gonna be root bridge, so both of them will be DP, RP, RP, DP block. Is switch 2 have this information that it can also reach switch 1 via 0 by 2? Is it receiving BPDU coming from switch 1 on its 0 by 2? No, because DP cannot receive BPDUs, as I said earlier on, right? DP will always transmit BPDUs, whereas non-DP will always receive BPDUs. So this time, switch 2 is receiving BPDUs only on 0 by 1, right? So switch 2 is having this information only that it can reach root bridge out from 0 by 1 only, whereas switch 3 is receiving BPDUs coming from root bridges on both interfaces 0 by 1 as well as 0 by 2. So in case if RP goes down, switch 3 can immediately put this alternate port into forwarding state if uplink fast is enabled on this switch, right? And in case if uplink fast feature is not enabled, then of course your convergence time will be 30 seconds. But at least switch 3 will never say that I am root bridge in case of if its RP goes down, right? But let's talk about switch 2. In perspective of switch 2, because switch 2 is receiving BPDUs coming from root bridge only on one interface, which is 0 by 1. So switch 2 is having this information only, that it can reach root bridge via 0 by 1 only. In case if this interface goes down, will it be possible for switch 2 to receive BPDUs coming from root bridge now?
No.
So if this RP goes down on switch 2, because of it was not having any alternate port available, so it will think that RP has gone down, and now it will start to announce itself as a root bridge. So this time it is gonna to announce itself as a root bridge, this switch 2, right? Because it cannot receive, I mean, it is not receiving BPDUs coming from root bridge on any other interface, right? So once it will say that okay, I am root bridge, so it will start to generate BPDU messages, and it will transmit those BPDU messages towards switch 3, I mean in the direction of switch 3. Now switch 3 was already having superior BPDU
Yes. That's it
from switch 1 on its 0 by 1, and now it have also started to receive BPDUs on its 0 by 2, that I am also root bridge. Means that switch 3 have experienced now two different root bridges, one is switch 1 and switch 2, but it was already having one superior BPDU coming from switch 1. And you must remember that max edge interval is by default 20 seconds, and this is for superior BPDU. What I mean to say by max edge timer, actually, that whenever a switch receives a superior BPDU, then it will always think that this BPDU is a superior BPDU for next 20 seconds. If it receives any other BPDU which is having, it will be having best bridge ID, but it is not gonna to accept it for next 20 seconds. Once your switch have received any superior BPDU, then it will always keep that BPDU as superior BPDU for 20 seconds. So because switch 3 already received the superior BPDU on 0 by 1, so this time whenever the switch 3 will receive this inferior BPDU, because now switch 2 is generating BPDUs in the presence of primary root bridge. So remember that if any switch starts to generate BPDU in presence of primary root bridge, then those BPDUs will be known as inferior BPDU. So in perspective of switch 3, whenever switch 3 will receive BPDUs coming from switch 2, will be known as inferior BPDU. So of course, due to max edge timer, because by default max edge timer is what? 20 seconds. So this switch 3 is not gonna to process all those inferior BPDUs coming from switch 2 due to this max edge timer only. Have you understood it now? So it is not gonna to process them right now. Once your max edge interval will expire, and one more thing, as I discussed in previous class also, that it is not exact 20 seconds actually. It's all about number of BPDUs. Once switch 3 will receive 10 inferior BPDUs. Once switch 3 will receive here 10 inferior BPDUs coming from switch 2, then it will immediately put this blocking port, this alternate port, into listening state. And as I said, in listening state, switch port can receive BPDU, can also transmit BPDUs, and also will elect its state, whether it will be DP or non-DP during listening state itself. Fine? Okay. Now switch 3 will, because switch 3 is still receiving superior BPDUs coming from, tell me, coming from switch 1, and also it was receiving inferior BPDUs coming from switch 2. Fine. So switch 3 will think that a BPDU coming from switch 1 is having best bridge ID, is not it? So this time what will happen, that switch 3 will put this interface into listening state, and it will make it DP, because it came to know that a BPDU coming from switch 1 is having best bridge ID as compared to BPDU coming from switch 2, is not it? And also will transmit a copy of BPDU in the direction of switch 2 during this listening state itself, right? So now switch 3 will put this interface into listening state as DP, and will also transmit one BPDU in the direction of switch 2. Once switch 2 will receive this BPDU here, so it will receive superior BPDU, because as compared to its own bridge ID, the bridge ID which is specified in received BPDU is best, right? So now switch 2 will receive this superior BPDU, and I have already told you that once a switch will receive a superior BPDU, it will always accept that switch as a root bridge. So this time, whenever this switch 2 will receive this BPDU coming from switch 3, it will accept this BPDU as a superior BPDU and will accept this switch 1 once again as a root bridge, and also it will stop to announce itself as a root bridge. So it will configure it as a new RP. So it will become RP. But you know, it was DP, right? So it was already in forwarding state, so it will directly switch from DP to RP and it will remain in forwarding state, but still it was in listening state at the end of switch 3. So it will remain there for 15 seconds and then finally it will move into learning state, and again it will remain there for 15 seconds and finally it will move into forwarding state. So it took approximately
50 seconds.
Switch 3 took approximately 50 seconds to put this 0/3 into forwarding state. Fine. 50 seconds. However, changes were occurred on switch 2. There is no direct link failure on switch 3 was there, but still changes are on switch 3, and it took approximately 50 seconds. So for switch 3, in perspective of switch 3, it was indirect topology change. It was not a direct topology change. In perspective of switch 3, it will be known as indirect topology change. However, for switch 2, of course, it will be direct topology change, because switch 2's directly connected port have gone down, is not it? So for switch 2, still you can call it direct topology change, but in perspective of switch 3, it will be known as indirect topology change. And as I said earlier on, that in case of indirect topology change, your convergence time will be 50 seconds, as you have seen here, right? Fine. It took 50 seconds. To reduce those 20 seconds which was taken by switch 3 due to max's timer, we can enable backbone fast. But remember, still it will take at least 30 seconds. That's why nowadays we do not prefer to use PVST, or you can say as TP, in production networks, because even after enabling everything like port fast feature, uplink fast feature, backbone fast feature, still your convergence time will be 30 seconds and you cannot reduce it. That is why finally they launched RSTP, rapid spanning tree protocol. So later on I'll be discussing this RSTP with you, that how RSTP converts quickly rather than this is TP. Fine. Should I implement this backbone fast, or you will be doing it by yourself? Remember, it's not like uplink fast, because backbone fast, I mean, it is necessary to enable this backbone fast on all switches, right? Because in case of uplink fast, it was necessary to enable uplink fast feature only on that switch which was having at least one alternate port. But this time, in case of backbone fast, it must be enabled on all switches. I'll let you know that why is it necessary to enable it on all switches, right? So first of all, let me do one thing. Let me create this diagram. Again, I will be having 3 switches here: switch 1, switch 2 and switch 3. So in between switch 1 and switch 2, I'm having 2 interfaces available. Show CDP neighbor, this 21 and 22. So let me shut down this 22 first of all. 22, let's set it down. Fine. So there will be only one link available in between switch 1 and switch 2. Then switch 1 and switch 3 are also interconnected with using 19 and 20. So I'm gonna to enable 19. Say no shut down. So it will be connected with switch 3 as well now. Then let's move on switch 2. Switch 2 and switch 3 are interconnected with using 23 and 24. So on 23, I will say no shutdown. So it will also be connected with switch 3. And switch 3 is connected with switch 1 and switch 2 with using 19 and 23. So except 19 and 23, I must shut down all other interfaces, right? So interface range fast Ethernet 0/20. Then to 22, and then so this time you will see that switch 3 will be connected with switch 1 and switch 3 only. Let me show you. Switch 1 and switch 2. See? So this time diagram is something like this. Switch 1, switch 2 and switch 3. Switch 1 and switch 2, switch 1 and switch 3, switch 2 and switch 3. Switch 1 and switch 2 are interconnected with using 21, 21. Switch 1 and switch 3 are interconnected with using 19, 19. Switch 2 and switch 3 are interconnected with using 23 and 23. Now switch 1 is having its bridge priority as 0. My God. So it's gonna to root bridge. It will become DP. Here DP, and here 21 will be RP. Here on switch 3, 19 will be RP. Fine. Any one of them, either switch 2's end or switch 3's end, will be DP, and another end will be in blocking state. Let me show you now. So switch 1 must be root bridge. Let me show you. Switch 1 is configured as root bridge, as you can see, right? And both of them are working as DP. Then you can also move on switch 2. So spanning tree. Let me show you that 21 is root port and 23 is what? Alternate. So this time let me disable this uplink fast from here. First of all, spanning tree, uplink fast, say no. So once again it will configure its default priority and default MAC address, right? And this time it have become DP. So this is your diagram. Actually this is DP and it is gonna to be in forwarding, sorry, in blocking state. So this is your diagram. This is existing diagram now, right? So you know very well that if on switch 3 this RP goes down, then definitely it will take like approx 30 seconds to move into forwarding state. Fine. But in case if switch 2's RP goes down, this one, it will start to announce itself as a root bridge, and it will start to send BPD in the direction of switch 3. It will receive here inferior BPD, will wait for 20 seconds, then it will take another 30 seconds to put this interface into forwarding state as DP, and then finally it will become RP. But overall convergence time will be 50 seconds. So let's prove it now. So first of all, let's move on switch 3, and you can see that on switch 3, 23, so spanning tree, let me show you, 23 is in blocking state. So let me say debug spanning tree events, and now let me move on switch 2. On switch 2 I'm gonna to shut down this 21 now. So it will say that I'm root bridge now. See, it is saying this bridge is the, and now switch 3 is gonna to receive this inferior BPDUs. It's not it, but still you can see that 19 is in blocking state, but just after receiving 10 inferior BPDUs, it will put, see, this 23 into listening state, and then it will remain there for in listening state for 15 seconds, and finally it will move into learning state. Again it will take 15 seconds, and finally it will move into forwarding state. So it will take at least 50 seconds, and it have proved now. See, we can also count total number of received inferior BPDUs here. Like you can see here, 1, 2, 3, my God, 3, 4, 5, 6, 7, 8, 9, and this is 10th. At same time, it have also put it into, after receiving 10th inferior BPDU, it have immediately put this interface into listening state, right? So because by default BPD interval is what, 2 seconds, so approximately it took 20 seconds, and then after 20 seconds it put this interface into listening state, and then learning, and finally forwarding. So it took 50 seconds. Again, let's move back on switch 2 and on its FA0 by was that 21. Say no shutdown. And again you will see that all interfaces will move in their default state. And this time I'm gonna to enable backbone fast on all switches, right? So I'll show you that after enabling backbone fast, it will reduce your 20 seconds. What will happen after after enabling backbone fast here actually? Once this RP will go down, it will again start to announce itself as a road brace. It will send inferior BPDU towards switch 3. Previously it waited, switch 3 waited for 20 seconds, but this time it is not gonna to wait for 20 seconds, right? Just after receiving very first inferior BPDU here on its blocking port, it will immediately generate route link query request message. It will immediately generate RLQ request message, switch 3. And remember, this RLQ request will be generated in the direction of route bridge only. Switch 3 is gonna to transmit it out from RP just to ensure whether route bridge is available or not available. Fine. So if backbone fast is enabled, then only switch 3 will be responsible to generate this RLQ request just after receiving very first inferior BPDU. So just after receiving this very first inferior BPDU, this switch 3 will generate this RLQ request out from its RP. So this route bridge is gonna to receive this RLQ request. Now, in case if backbone fast is not enabled on this switch 1, it will immediately drop this RLQ request because it will not be possible for this switch 1 to understand this RLQ request. Fine. But in case backbone fast is enabled on this switch 1, then it can easily understand this message RLQ request, and also if the switch 1 is available, if it is announcing itself as a route bridge, then it will also provide RLQ response, route link query response towards switch 3. Just after receiving this RLQ response, now switch 3 will get ensure that route bridge is still available. There is no problem on route bridge, right? And then immediately this switch 3 will put this blocking port into listening state, and also will transmit a copy of that BPDU coming from switch 1 in the direction of switch 2. So whenever this switch 2 will receive this BPDU, then it will receive a superior BPDU. Just after receiving the superior BPDU, the switch 2 will immediately stop to announce itself as a road bridge. And this time, because this switch 3 have already put this blocking port into listening state, so it will take only 30 seconds, will not take 50 seconds this time. Fine, let me prove it now. However, it is not necessary to enable backbone fast on switch 2 in this topology. It is not really mandatory to enable backbone fast on switch 2 because of course it will never participate in the messages of backbone fast. But yeah, it is mandatory to enable it on switch 1 as well as on switch 3. However, it is always recommended to enable this feature on all switches, right, in your switch network. So I'm going to enable this backbone fast now. So let me do one thing, spanning tree, what? Backbone fast. Then on switch 2 also, even you can check it whether backbone fast is enabled or not by configuring this command, show spanning tree, backbone fast. So what is it showing? Backbone fast is disabled. So to enable it, say spanning tree, backbone fast. Then say show spanning tree, backbone fast. It will show you that backbone fast is now enabled. Then you can also move on switch 3 and then you can say spanning tree, backbone fast. Just after enabling backbone fast, let me show you. Of course, it is still having this 23 in blocking state. It's not it. And let me show you debug spanning tree events, debug spanning tree, backbone fast. And also I will move on switch 1 and also I will say debug spanning tree, backbone fast, right? After enabling debugging on switch 1 as well as on switch 3. I'm gonna to shut down this 21 on switch 2. Debug spanning tree events. Fast is ranked 1 by 0 by. So you will see immediately it will announce itself as a road bridge. Switch 3 is going to receive very first inferior BPDU, but just after receiving very first inferior BPDU, it have transmitted one RLQ request out from 19, and 19 is what? RP, going towards switch 1. So switch 1 will receive this RLQ request now. So let's move on switch 1. It have received RLQ request on 19 and also have given back RLQ response. Is not it? Just after receiving this RLQ response on switch 3 have put this 23 immediately into listening state, just after receiving very first BPDU. Is not it? And the process of transmitting this RLQ request and RLQ response have been completed within some milliseconds. This process is quite fast. You can see 5432, 5432. However, in debug messages it is not showing me milliseconds. But you can see that second have not been changed. It means this process got completed within some milliseconds. That is why it have not received next BPDU, next inferior BPDU. Before receiving next inferior BPDU, it have put this interface into listening state. And after putting this interface into listening state, switch 2 received one superior BPDU, hard root and supersedes. Is not it? It means it have received one superior BPDU. That is why now switch 2 will configure its 23 as a RP now. And switch 3 have also put this 23 into forwarding state as a DP. You see? So this time it took approximately 30 seconds. It didn't took like 50 seconds. But now you cannot reduce these 30 seconds by using anything. Even you can also enable uplink fast, but because uplink fast will work in case of if your RP goes down, primary RP goes down, so that it will immediately put your alternate port into forwarding state, your blocking port into forwarding state. So I hope that now you have understood the uses of uplink fast, the uses of backbone fast, uses of port fast, and also I have taught you that how to enable all these features. Remember, uplink fast and backbone fast cannot enable per interface basis, but port fast feature can enable per interface basis as well as globally. So it will be depending on you that how do you want to enable this port fast feature on your switches, right? So sometimes in questions they will ask you that use only single command to enable port fast feature on all access ports, right? So you will enable it globally, and the command will be spanning tree port fast default. So I hope that now you have understood the uses of all these things, all these STP characteristics or whatever you want to say. Have you understood all these things now?
Yes, sir.
So actually I also wanted to cover your STP protection actually, because now we have completed this STP. Apart from it, I can also teach you that how to manipulate your root bridge election and RP election. Do you want to learn that how to manipulate your RP election and how to manipulate your root bridge election? Like for an example, by default switch 1 have been elected as a root bridge, right? Let's say that switch 1 is not having a very good hardware configuration, but switch 3 is having very good hardware configuration, right? And you want to configure the switch 3 as a root bridge now. So what will you do? You will say spanning tree. Yeah, now you can configure the switch as a root bridge for some VLANs, because by default STP do not run on your switches. By default PVST plus is running on your switches, right? Because in case of STP, of course it must run CST, common spanning tree, right? But CST is not supported by Cisco switches at all nowadays, right? And Cisco implemented its own protocol which is known as PVST plus. That is why if you are having multiple VLANs on your switch, for an example, let me show you. Say on all, and then after enable spanning tree. Sorry, first of all create VLANs, some of the VLAN, let's say 1 to 10. So you will see that the switch will run an individual instance for each VLAN. See, for VLAN 1, for VLAN 2, for VLAN 3, for VLAN 4, for VLAN 5 and all, right? Even you can also see output in this manner as well. So spanning tree VLAN 1, so spanning tree VLAN 2, so spanning tree VLAN 3, so spanning tree VLAN 4. So I think now I should start all these things in next class, because it's already 11:50, right? And one more thing,